Myself, Dr. Amarnath Shetty, Professor in AG Civil Department, Mangalore. Now, I will explain the important question of water supply and treatment engineer, Module 3. First question: what is sedimentation and factor influencing sedimentation, theory and their type? Total explanation of the sedimentation. It is a process which suspended solids are made to settle by the gravity under still water conditions. Okay. Then we go for plain sedimentation. Okay. What are the plain sedimentation advantages? Following advantage: plain sedimentation lighten the load of the subsequent process. The process of subsequent purification process can be controlled in a better way. The cost of cleaning and chemical coagulation basin is reduced. No chemical is lost sludge discharge from the plain settling basin. Less quantity of chemicals are required to subsequent treatment process. Factor influencing the sedimentation. Okay, first one, size, shape and weight of the particle, velocity and temperature of the particle, viscosity and temperature of the particles of the water, surface overflow rate, velocity of flow, inlet and outlet arrangement, detention period, effective depth of basin. Okay. Now we go for the theory of the sedimentation. The settlement of the particle in which when brought to rest is opposed by following factor: the velocity of flow which carries the particle horizontally, velocity of the water which particle is traveling, the viscosity varies inversely with the temperature. Okay, the size and shape of the septic gravity of the particle. The greater is the specific gravity, more ready the particle will settle. Okay, any particle which does not alert its size, shape and weight while rising or settling in any fluid called discrete particle. All the particle having specific gravity more than liquid which ready to move down due to the gravity force. When any discrete particle falling through the sequent fluid, okay, it will accelerate until the frictional resistance and drag the force become the gravitational force acting upon the particle. Such state particle will settle uniform velocity. This uniform velocity is called settling velocity and is a very important factor. Second law. Okay. Following a discrete particle given by S is the specific gravity of the particle, S1 is the specific gravity of the water, G is the acceleration due to gravity, 9.8 998 centimeters per second. D is the diameter of the particle, R is the kinematic velocity of the particle, centimeters per second. Okay, limitation of the Stokes law. Okay, Stokes Stokes consider the particle are sphere, but particle is not possible. All the particle will not perfect sphere. Okay, Stokes uh, does not hold good particles of size less than 0.1 mm, which settle with the velocity varying as the first power of their diameter are not varying the square of their diameter. For a settling velocity, discrete particle given by V is equal to 418 S minus S1 d square 3t plus 70 divided by 100. Okay, V is the velocity of settlement in mm per second. S is the specific gravity of the particle. S1 is the specific gravity of the water. D is the diameter of the particle in mm. T is the temperature in centigrade. Okay, diameter of the particle greater than 0.1 mm. Then the velocity is measured by V 418 S minus S1 D 3T plus 70 divided by 100. Okay, the particle settling of the particles governed by the restant of the horizontal velocity water and vertical down of the velocity of the particle. Okay, types of the sedimentation tank. First one, nature of working, fill and draw type, continuous flow type. First one, nature of the working, direction of the flow, a horizontal flow basin, vertical and upward flow basin, radical flow basin, spiral or circumferential flow basin. Next one, shape, rectangular tank. First one, horizontal tank, hooper bottom tank. These are the types of the sedimentation tank. Okay, in a plate sedimentation, nature of the working, fill and draw type, continuous flow type, direction of flow, horizontal flow basin or vertical upward flow basin, then on radical flow basin and spiral and circumferential flow basin. Shapes, rectangular tank, circular tank and hooper basin tank. Okay, nature of working. Now we go for the nature of working. Okay, fill and draw type. The raw water is allowed to rest on the basin sometime. During that time, suspended particles settle down at the bottom. Okay, bottom. The clear water is drawn off by the deposit are cleaned, then the basin are refilled and its action continues. This is the you can see the this one. Okay, fill and draw type. This is the tank. Okay, inlet raw water. It is kept in a tank. Okay, for some time and pure water is removed. Okay, deposit are removed. Okay. Now continuous flow type. This is the continuous flow type. You can see the continuous flow type. Okay. Raw water is allowed to flow continuously with a small uniform velocity when the detention time of the suspended particles settle down at the bottom before they reach exits. The inlet and outlet flow design that causes least disturbance to the flowing of the water. Okay, this is the inlet chamber. Okay, raw water will come here. Then it is moves in zigzag ways and vessels. Okay, this way. This is the continuous flow of tank. Next one, direction flow. Okay, direction flow. The horizontal flow direction. It is a rectangular plan having the length of twice the breadth. Floor is given as a sludge. This one vertical upward basin. The deep and circular rectangular hooper at the bottom. Okay, the raw water entered vertically bottom and centrally located inlet pipe. The suspended particle drawn at the hooper bottom and collected to the sludge pipe. Okay, this is the vertically upward flow basin. Okay, sludges are at the down and it moves upward water, raw water and flows and it is like a circular sedimentation tank, same as the circular sedimentation tank. Okay, now we go for radial flow basin. Okay, water enter through the inlet pipe. Inlet pipe are enclosed with the deflector balls, which is deflect the flow downward. The flow goes out radically toward the circumference of the tank. During the radical flow, all the settleable particles settle down. This is the, we can see the radical flow, okay, settling tank, flow basin, okay. Now we go for the spiral circumference flow basin. This we can see spiral or circumferential flow basin. Water enter in the tank through the 2 or 3 vertical slits of the inlet channel. Rotating arm is provided in the tank. It makes all the water to move circumferentially. As the flow of water is very slow, all the settleable particles settled at the bottom of the tank. Clear water drawn to the very tight outlet. Okay, This is about the spiral or circumferential flow basin. Okay. Next, we go for the shape. This is a very important shapes. There are two to three types. Okay. One is first. Okay, rectangular shape. Rectangular sedimentation tank is made up of concrete mainly. It is rectangular in shape. The length of the flow takes place in the horizontal direction lengthwise rectangular tank. Some bevels walls are provided to prevent the short circuiting. Maintenance cost is low at the rectangular sedimentation tank. Okay, they are suitable for large capacity. Okay, tank. This is the, we can see the rectangular sedimentation tank. Okay, it is in rectangular shape. Here is the inlet of the tank. Okay, inlet with water will stay here. Detention time 5 hour or 4 hour, 3 hour, depend upon the quantity of the water and quality of the water. Okay, and all the sludges will come down. Okay, all the sludges are removed from here after the pure water is taken out. Okay, this is the outlet. Okay, where the pure water will move outside, and sludges. This is very important for a large area. Okay, water supply. Okay, this is made up of concrete. It is okay, rectangular in shape. Okay, this is a water level freeboard. Okay, this is mainly used in this one large this. Okay, and then we go move for the circular sedimentation tank. Okay, circular sedimentation tank. This is the circular sedimentation tank. Preferred continuously velocity flow through the sedimentation tank. In this case, influent is sent through the central pipe of the tank. Radically flow take place. Mechanical sludge scrapers are provided to collect the sludge and collect the sludge carried through the sludge provided at the bottom. But the circular tanks is uneconomical as compared to rectangular, but a high clarification efficiency. Okay, this is the circular tank. Okay, circular tank. You can see the circular tank. It is made up of concrete or okay, and steel or this one. Okay, the inlet pipe raw water will come in inlet. It will move here and settle here. Okay, according to detention period. Okay, sludges are come down and collected. Sludges are downward and collected sludges. Okay, sludges are removed from the sludge collecting truck. Okay, this is the main process of the sedimentation tank. Now we go for the displacement efficiency. Very important displacement efficiency of the tank. For effluent removal of the sedimentation is necessary that the flow is uniform distributed throughout the cross section. However, actual practice certain amount of short circuiting always exists. The permits of the sufficiently amount of water passes through directly through the tank without being detained. Okay, internotes the time. Therefore, the actual average time flow, the average time required the particle passes through the basin given rate is called flowing through period. Okay, this is always less than the detention period. Corresponding theoretical time reflect the efficiency of the basin determined by the ratio observe the flowing through the period of theoretical detention time. It is also called displacement efficiency. Okay, uh, okay, thanks.